All right. Thank you, Dan, for this introduction, and also for inviting me to give this presentation today. This is actually the first time doing such a presentation, so I'm really happy to be able to share some of my thoughts on the impact of conventional energy systems on the environment. And I also would like to thank my co-author, Christopher Zadigwu, for his contribution to this presentation. So first of all, I would like to really quickly define what do I mean by conventional energy. I'm referring to the non-renewable energy resources, including natural gas, coal, oil, uranium, which obviously is a resource that's going to be used for producing nuclear energy, and any electricity from non-renewables. So I think the last point is also really important, because we typically think that when we have electrical cars, we are driving electrical cars, we are using renewable energy, which not necessarily is the case. Okay, so that all depends on where the electricity is coming from, or how the electricity is being produced. And secondly, my presentation in terms of the impact on the environment, I'm going to be covering the soil, the water, the air, and the water. So I'm going to present a few of my thoughts on each of those environmental components or ecosystem components individually in that order. And then at the end, I'll try to pull them together as well. So the first one is about the impact of conventional energy systems on the soil or on the landscape. And really obviously, and I'm sure you have seen many pictures like this before, that a lot of the conventional energy systems will cause a huge surface soil disturbance. Like this one, this is taken from the oil sands, and the data on this graph is also based on the oil sands as well. So a huge area could be disturbed if the conventional energy resource is being mined through surface mining. And as a result of that, large areas would need to be reclaimed. And so this figure again shows that a lot of surface area disturbance. And currently, again, just using the oil sands as an example, currently a really small fraction of the disturbed area has been reclaimed or certified in particularly. Okay, so a lot more disturbance that needs to be dealt with. So this is obviously a really large impact of some of these conventional energy systems to the environment. The second one is what we are also familiar with, is that through the exploration for the conventional energy, a lot of linear disturbance would have been created. So in Alberta, for example, we have more than 1.8 million kilometers of seismic lines that's been distributed across the province. And this picture shows these seismic lines on a really nice aerial photo, a close-up of example of a seismic line disturbance. And this one is a 2 hectare of wooded land had been raised by explosion. This is in the northern Alberta, that happened in 2009. And so those are really obvious disturbance that's being caused to the soil, to the ecosystem. But there are some hidden influences or hidden impact of these disturbance regimes on the ecosystem, on the soil. In this case, this is based on some work by Maria Struck. She used to be with the University of Calgary. I think she moved back to the east. I forgot which university she went to. But their recent work indicates that even in these seismic lines, This is more looking at a wetland type of ecosystem where the disturbance by removing the canopy, changing the thermal condition of the soil, changing the hydrology, raising the water table would increase the methane emissions. And this obviously, as you all know, that this is a fairly potent greenhouse gas. And so those are some of the impacts that could be caused by the exploration of conventional energy in this country. This is an article published a few years ago by David Schindler's group, and they were looking at the oil sands mining and its influence on the loss of wetlands and soil carbon. Loss of wetlands would be fairly obvious, but we may often forget that the loss of wetlands would also mean loss of soil carbon and the loss of the wetland function, where it would be sequestering carbon. But when we lose these wetlands, the sequestration carbon function would also be lost. Moving on to talk about the environmental impact in terms of soil and water contamination that could be caused by these conventional energy systems. So we're looking at potential contamination by petroleum hydrocarbon, heavy metals, and other toxic chemicals that could be released through these conventional energy production systems. Waste materials such as the sulfur stacks that are a waste material as a byproduct of the oil sands energy production system. And so those waste material have to be dealt with, such as the petroleum coke as another example of waste material that would have to be dealt with. And in Northern Alberta, again, in the oil sands, more than 1 trillion liters of OSPW, oil sands process affected water in the tailings ponds in Northern Alberta. It's obviously a really big eyesore to many people, and those are some of the environmental impacts that we would have to be dealing with as well. A lot of these conventional energy would, during their production, during their storage, during their transportation, there's a risk for spillage. For example, in the United States, spillage from tanker accidents amounts to about 60 per year. And also in the US, about more than 1 million liters of petroleum is spilled into the coastal waters. And so again, those amounts to a huge environmental impact. In the Canadian soil, such accidents such as spillage and contamination of the soil and water you would frequently occur as well. This is back in 2013, but if you pay attention to the news, these spillage would occur very, very frequent, right? We have derailment quite often occur. Another form of contamination is these soil and water contaminations through these petroleum storage tanks. A lot of them may leak and causing large number of sites, contaminated sites. So this is the number, you'd be looking at thousands. So this is a news article which published a few days ago, February the 16th, 2022, accusing the Alberta government hiding some of the contamination problems, contaminated sites. But I don't necessarily think this article is, that the government is necessarily hiding these numbers. Those numbers are available on the internet and so forth. But the key is the key message here is that the number of sites are really large, and this also points to the scale of the problem that we are facing in the province. Moving on to talk about the impact on the air. Okay, checking on my time. So these conventional energy system, for one thing, the production of these energies themselves can be quite energy intensive. For example, in the oil sands, as an example, the greenhouse gas emissions, this is based on 2013 data, makes up 8.7% of the entire greenhouse gas emissions in the country. So this obviously is fairly highly significant. The oil sands operations on an annual basis emits about 70 million tons of CO2 on an annual basis. The other point, I think, in terms of climate change, as far as the climate change is concerned, is that these conventional energy all emits carbon dioxide or greenhouse gases through the combustion of those fossil fuel, right? So the combination of annual fossil CO2 emissions, coal, hopefully with the restrictions on the usage of coal, or many developed countries restricting the use of coal as an energy source, this emission is going to be decreasing. But oil and gas emissions of carbon dioxide, carbon emissions from burning of oil and gas obviously are going to be continued unless we replace them with alternative energy sources. Another impact of the conventional energy systems on the air is obviously emission of pollutants. Here, the example is emission of ammonia in the oil sands. So really obvious that where the oil sands operations are really intensive, the emission, the ammonia concentration in the air is really high. And these type of nitrogen and sulfur emissions from energy production systems would enter into the atmosphere and eventually would be coming down in the form of acid deposition or nitrogen and sulfur deposition. Okay, and these acidic deposition would then cause soil acidification. This is the data coming from Alberta. Long-term soil acidification monitoring, we're seeing a reduction in the soil pH caused by acid deposition going from the 1980s all the way to the 2000s. Okay, so this again illustrates the impact of the conventional energy production systems on the air quality on the air. Moving on to talk about the effect on the biota. Obviously, the disturbance, the surface disturbance I mentioned earlier, is going to damage the ecosystem, removing the vegetation and cause damage to the soil, fauna, etc. as well. Exposure of the biota, such as animals and human beings, to the polluted air, water, and soil, obviously will be causing significant influences on the biota. Okay, fossil fuel combustion is going to cause a lot of pollutants, particulate matter as another example where it's going to pollute the air and influence human health. So the discussion so far has been focusing on each of those ecosystem components or environmental components individually. But if I could use the global biogeochemical cycle of vanadium as an example, it's really clear that the influence of these conventional energy production systems on the soil, water, air, and the biota is really well connected. So we really have to think about them as an integrated system. We can't really separate the impact on these different components individually. Everything is connected, and we have to really evaluate them as a system. And I know I have used up my time. I have 2 more slides to really quickly go through. So why, you might be asking, why are we still using these conventional energy? There are a few points we have to consider. That conventional energy obviously has its own advantages. They may be cheaper to use. We have the technologies to use them, and by convention, right? The second thing is that emission intensity has been decreasing. So we are improving our technology. We are using new methods to extract the conventional energy resources to cause less disturbance. We are developing clean air technologies. We are trying carbon capture and storage to reduce our impact. But regardless, alternative energy sources are obviously urgently needed. In terms of some of the disturbances, we are developing reclamation techniques to deal with that. And Danny is obviously going to come back to talk about this in a lot more detail. And my last slide, as a really quick summary, the use of conventional energy comes obviously with a really large environmental cost. Some of the environmental impacts can be mitigated, however, and more sustainable energy sources will replace conventional energy in the long run. This is what I believe, and this is obviously what we are looking forward to. Thank you.